CrosseMaths lesson. Today we're going to be looking at similarity. Okay, right, what I'd like you to do, pause the video now for me, have a go at the challenge grid in front of you. Okay, there's a range of topics, probably about 30 marks in a real GCSE exam by there. Get as much of it done as you can, and once you're finished, I'm going to go through it. Right guys, so you should be all done. So what I'm going to do, I'm going to go through each one individually. Now, factorise and solve. What this is asking you to do, this is factorising into a double bracket. Okay, very, very straightforward maths, especially if you're already higher tier. Okay, so we're going to put this into a double bracket. Okay, it's like going backwards. It's like the backwards version of expanding using FOIL. Okay, so I'm going to put this into a double bracket, and it's still going to be equal to 0 like it is in the question. So I'm going to have x and x. Okay. Now we're going to look for two numbers. We need to find two numbers to fill our bracket. They're going to multiply to make 8 and they're going to add to make 6. They're both positive, so this is going to be a really easy one. The numbers I'm thinking of are x plus 2 and x plus 4. They add together to make 6 and both multiply together to make 8. So that's our brackets filled in. Now we've got to use this bracket. Once we factorise it, we've got to solve to find out what x equals. Now x could equal one or two things with x squared questions. Okay? X will have to make one of the brackets to equal 0. If it makes the left-hand bracket equal 0, x would have to be negative 2. If it cancels out the right-hand bracket to make 0, x would have to be negative 4, because there's a plus 4 there already. Minus 4 plus 4 would make nothing. It has to do that because the whole thing is equal to 0. Because it's equal to 0, one of those brackets has to be 0. For something to times together to make 0, one of the things has to make 0. So my two answers for x equals minus 2 or x equals minus 4. That would be 3 marks in a real exam, 2 points now. Bit of standard form, okay? When you're dealing with standard form like this, okay, there's a key rules you need to follow. The two front numbers, these normal numbers, you're going to do normal maths with them. I'm going to divide 8 by 4. 8 divided by 4 gives me an answer of 2. And then when you've got your powers, you've got to take them away. So my answer is 2 times 10. I've got 10 to the power of 6 and 10 to the power of 3. If I subtract those, I end up with 2 times 10 to the power of 3, because 6 take away 3 is 3. That's my final answer. Next, a bit of indices, okay? A couple of things here. I've got my half rule, which means square root, and I've got my negative rule, which means reciprocal, which is write it as a fraction, essentially. So I'm going to use the negative rule first. I'm going to write this as a fraction, so instead of 25, I'm going to write down 1 over 25. Is still to the power of a positive half. Then power of a half means square root. So it's the same as square root of 25. Square root of 25, it just gives me 5. Okay, very straightforward, probably worth 2 or 3 marks on a day. Right, 0.4 recurring as a fraction, okay, so I know my formula is x equals 0.444444 going on forever. Okay, I need to get that first recurring digit over the decimal point. To do that, I'm going to times by 10. So I end up with 10x on the left, 4.4444 on the right. Okay, I'm going to take my first line, I'm going to write it underneath. X equals 0.4444. And those who have done this question before will see what I'm trying to do. I'm trying to line the 4's up, the ones after the decimal point. And if I take away, these cancel out with each other. 4 take away 0 is 4. 10x take away 1x is 9x. 9x equals 4. If I divide through by 9, I end up with x equals 4 over 9. You've written it as a fraction. Very, very straightforward. Simplify inserts. Okay, this is just expanding using FOIL. If I times my first two numbers by each other, 3 times 6 gives me 18. Then, if I times my outside edges, 3 times 2 root 7, you do the 3 times the 2, which is 6. So my answer is negative, because it's a negative 2, minus 6 root 7. Inside edges, 4 times 6. 4 times 6 is 24. There's going to be a root 7 on the end, because it's not just a 4, it's a 4 root 7. So 24 root 7. Okay, and then my last two numbers, this is the difficult one, okay? 4 times... It's going to be 4 times minus 2 is going to be a negative. So 4 times minus 2 is minus 8. Root 7 times root 7 just gives you 7. 8 times 7 gives us 56. So my answer is negative 56. Okay, I've done that all in one bit, but you'd have to do it individually on the day. Once I'm there, 18 and negative 56 go together. I think they make minus 38. And then minus 6 root 7 plus 24 root 7 is the same as doing minus 6x plus 24x. Okay, it's just simplifying like that. So minus 6 root 7 plus 24 lots of root 7 will give me positive 18 root 7. Very straightforward, 2 points. Okay, finding the value of x in this. Okay, this is circle theorems. Okay, when you've got the arrowhead shape, okay, the rule is, and this is the important thing, you've got to remember your rules. When you've got the arrowhead shape, the rule is the angle at the centre is double angle at the edge. Okay, you need to write that in a full sentence. I've abbreviated by there. Angle at the centre is double the angle at the edge. So the angle at the centre is double the angle at the edge. If I do 68 divided by 2, x is going to be 34 degrees for x. Very straightforward question. It's important you learn your circle theorems rules. That one comes up a lot. Okay, a little bit of trigonometry now. Find x where 5 centimeters on the bottom, 9 centimeters going up top. Okay, what I do with trigonometry, follow the same steps every single time. Step 1, I label my sides. Okay, my long side is called my hypotenuse. Lots of you will know this already. My angle is x, so this side over here is called my opposite side because it's opposite the angle I want to find. And this side down by here is called my adjacent. Okay, so I've labelled my 3 sides. Once I've done that, in trigonometry I write down SOHCAHTOA. The reason we do that is this is going to tell us whether we can use sin, cos or tan. And that's the only thing you really need to choose when you're doing trig questions. Okay, once I'm there, I'm going to cross off the side that I don't need. Now you'll notice the hypotenuse has got a 9 centimeters on it, adjacent's got a 5 centimeters on it, opposite's got nothing. So I'm going to cross opposite off because the other two have numbers. I need those two. I don't need opposite for this question. So opposite's going to go. Because ca is the only one with 3 digits remaining, that's the one I'm going to keep. So my ca triangle looks something like this. Okay. Now I want to find the angle x. So x equals. Now if you take your thumb and you cover the c bit, which is the angle, you'll be left with a over h. Okay, if you cover the c bit in the triangle with your thumb, you'll be left with a over h. That's your working. So my a is 5. My h is 9. And remember, when you're finding an angle, it's always cos to the minus 1. Okay. Cos to the minus 1, I'm going to take my calculator, put all that in, press shift, then cos, 5 divided by 9, gives me an answer of 56.3. 56.3 degrees. Okay, that's that one done. And that's all trigonometry is, it's those same steps, okay, just get them in your head, get them ingrained. Right, making x a subject. Okay, this could be a difficult one, but I think it's going to be okay. Okay, all we do is expand first. So a times x, expand this first bracket. A times x is just ax. A times b is just ab. D times x is just dx. D times negative c is negative cd. Once done there, all I've done is expand my brackets. That's 1 mark already. Very, very straightforward. Year 7s can expand brackets. Once I'm there, I've got to get anything with an x in on the left-hand side, anything without an x in on the right-hand side. Okay, so I'm going to need to get this dx over here. So what I'm going to do, okay, can I make this any, there we go, that'll do. What I'm going to do, I'm going to take away, once my iPad catches up with me, I'm going to take away dx on both sides. If I take away dx on both sides, I end up with ax plus ab. Take away dx because it's come over the equal sign. The dx on the right hand side now is gone, minus cd on the end. Okay, so all that's happened so far is the dx has moved over and it's turned to a negative. Next I'm going to take away ab from both sides. I end up with ax plus ab minus b, and baby makes nothing. Take away dx equals minus cd. Take away another ab. Okay, once I'm there, I've got an x and an x on the left. I don't want those two together. I want x on its own, so I don't want x with an a or a d. So I'm going to take it out as a common factor. X on the outside, a take away d on the inside of my bracket. So I've just done simple factorising to get x on the outside of the bracket. Minus cd minus ab still over here. Now once I'm there, my last line, I'm going to divide through by ad. So x equals minus cd minus AB all over A take away D. So you'll notice all of the steps I've followed there are really straightforward solving equation steps, but you're not going to get a final answer and there's a lot of letters going on. But just follow your simple steps and it should be okay. Right, last one, okay, find the HCF and LCM of 42 and 105. So the first thing I'm going to do my prime factor trees for 42 and 105. 42, if I break it down, breaks down into, just going to get a liner on that, 42 breaks down into 6 and 7. You circle if you get to a prime number, so 7's prime. 6 breaks down into 2 and 3. 2 and 3. Okay, that's done. Then I do the same thing for 105. 105 breaks down into 5 and 21. 21 breaks down into 3 and 7. Okay, so I've done those. Once I've done that, I do a Venn diagram. Now, you'll all be familiar with a Venn diagram, okay? Now, I've got to fill the numbers in for this Venn diagram using the numbers with circles around them. Look at the two sets of numbers. Look at the ones that are the same. The ones that cross over and are the same, they've both got a 3 and they've both got a 7. Okay, if you use the 3 and the 7 for the 105, all you got left is a 5. If you use the 3 and the 7 for the 42, all you got left is a 2. So that's my Venn diagram filled in. The HCF is just the middle bits times together. So the HCF is 3 times 7, which is 21. So the 21 would be the biggest number that goes into 105 and 42. Now the LCM is the lowest common multiple. What that means is the lowest number in the 105 and 42 times table where they cross. So the lowest common multiple is everything times together. So the lowest common multiple is 2 times 5 times 3 times 7. Okay, 2 times 5 times 3 times 7 should give you 210 for the LCM. Right guys, so hopefully you've got all those written down. Okay, mark whatever you've done so far. Okay, hopefully you got somewhere around 12 to 15 correct. Okay, if you're honest with yourself, that's really, really good. And that's where you should be about in higher tier. Right then, so similarity. What similarity means is two triangles are similar if all the angles are the same and one is just a lot bigger than the other one or one is just a lot smaller than the other one. They're similar shapes, so they look similar, but one is just a lot bigger. Usually it means one has been stretched by a certain amount. Okay, if you look at the two here, you'll notice that there's two sides that correspond. Now a corresponding side can either mean we've got both of the bottoms have got the numbers filled in, both of the lefts have got the numbers filled in, or both of the hypotenuse are filled in. Okay, you'll notice both of the left-hand ones for R1 are filled in. I've got a 3 and a 7.5. Okay, so what I'm going to do, I'm going to divide them, because I want to find something called the scale factor. Now the scale factor is just going to tell us how many times bigger the big one is. So if I take the two numbers, I do 7.5 divided by 3, gives me 2.5. So what that's telling us is this big shape is 2.5 times bigger than a little shape. And this little shape is 2.5 times smaller than the big shape. So if I want to find side C, for instance, side C is 2.5 times bigger than the side 4 on the left hand side. So I'm going to take that side 4 over here. I'm going to times that by my scale factor of 2.5. So side C will be 4 times 2.5, which would give me 10 centimeters for side C. And that makes sense. Side D is the hypotenuse on the smaller one. Now that is 2.5 times smaller. So I've got to take my 12.5 on my big shape and divide it by 2.5 because it's 2.5 times smaller. Side D then will be 5 centimeters. Okay, so you've shrunk it by dividing by 2.5. Pause the video now, guys, get that copied down. Right then, so moving on. Okay, what I'd like you to do, pause the video for me, have a go for yourself. I'd like you to find side X. Right then, so you'll notice that these aren't triangles, okay? Most of the time you will be dealing with triangles, but similarity counts for all shapes. Okay, if two shapes are similar. Now I want to find the scale factor first. So scale factor is the two sides that are corresponding divided by each other. So I've got this 4 and it's 20. 20 divided by 4 gives me a scale factor of 5. Okay, and that's the important number. That's telling me this is 5 times bigger and this is 5 times smaller. Now we want to find side X. That's 5 times smaller than 30. So side X equals 30 and I'm going to divide it by 5 because I want to shrink it. 30 divided by 5 is 6 centimeters. Okay, similarity is very straightforward when you're dealing with a basic version like this. Right then guys, so mark whatever you've done. Hopefully you understand that. What I'd like you to do, can you have a go at this, you doing a little bit of similarity with the shapes in front of you, please? Pause the video and have a go. Right guys, what you should have gotten something that looks like this, okay? All of your answers should look like that. Okay, if you have got any queries or you found them difficult or you think, I don't know how you got that answer, please just give me a DM, take a photo of your answer and give me a DM and I'm happy to help you. Right, so that's similarity when it comes to lengths, okay? What you'll find at higher tier is you end up dealing with areas and lengths, okay? They mix them in and sometimes they put volume in as well. When you're dealing with area scale factors, okay, it's slightly different. Okay, so what you need to do, okay, so we can find our normal scale factor for these two triangles on the left. Okay, I can do that by doing, I got 5 and 15, so my scale factor, I'm going to use SF just to abbreviate it. SF is the two sides that are corresponding divided by each other is 15 divided by 5. Gives me 3 centimeters. Not 3 centimeters, sorry, just 3. So my scale factor is 3. So I know this big triangle is 3 times bigger, and this little one is 3 times smaller. Now that only works with length. Area scale factor is slightly different. Now, if you look at the difference between the units, okay, units for length are just centimeters. Units for area is centimeters squared. Okay, it works the same with scale factors as well. So in order to get from normal scale factor to area scale factor, you've got to square it. So area scale factor is the scale factor squared, which in this case would be 3 squared. So my area scale factor is 9. Now if I want to find the big area, I've got to take my little area, which is 8. This area is going to be area equals my little area, which is 8, times in by the area scale factor of 9. This big area is going to be 72 centimeters squared. Okay, and that's how it works. Okay, area scale factor is the normal scale factor squared. So if I wanted to go from area scale factor back to normal scale factor, I'd have to square root. Now over here is exactly what I was just talking about. Okay, you'll notice on the right hand side we haven't been given lengths. Okay, we've been given areas. Okay, so I've got my area scale factor to work out. My area scale factor, if I take my 2 and divide them, 250 divided by 10, 250 divided by 10 gives me 25 as an area scale factor. If my area scale factor is 25, I want to find my normal scale factor. I've got to square root my area scale factor. Okay, square root of 25 gives me 5. So I know this one over here is 5 times bigger, and this one over here is 5 times smaller. Now if I want to take my 4 centimeters and I want to find what x is 5 times bigger than 4, so x would be 4 centimeters times by my scale factor of 5, be 20 centimeters altogether. Guys, what I'd like you to do is pause the video now, get that copy down for me please. Right then, so a couple of questions guys, pause the video, have a go for yourself. A couple of ones only a little bit on very similar to the example I just did, so have a go. 1 and 2 are similar to example 1, 3 and 4 are similar to example 2. Right guys, hopefully you finished all those now and hopefully you got them right. Okay, if you didn't remember you can message me if you're struggling. Okay, ask your teacher. Okay, we're all here to support you. Okay, so that should be done. Now, this is the stuff that higher tier tend to have, okay? It will sometimes be area scale factor, but generally you get a lot of volume scale factors at higher tier, and they may not even give you a picture. So, area scale factor, so normal scale factor was just the two sides divided by each other. Area scale factor was normal scale factor squared, okay? We remember those things from earlier on. That's still in our heads. Okay, so the scale factor we've got here, we've got to take the two corresponding sides and divide them by each other. I've got a 10 and a 5. 10 divided by 5 gives me a scale factor of 2. Now, remember what I said, pay attention to the units. If you want to find out your volume scale factor, different to area. If you look at the units for length and volume, okay, this time volume is meters cubed. So my volume scale factor is my normal scale factor. This time we're going to cube it. So my scale factor is 2. So scale factor cubed, 2 cubed. My volume scale factor is 8. If I want to find out the big volume, okay, I'm going to take my 50 centimeters cubed. Okay. I'm going to multiply it by my volume scale factor of 8. 50 times by 8 gives me 400 meters cubed for my big volume. And that's essentially it, because you're stretching that small volume by the volume scale factor. Same thing on example 2, but again, we haven't been given the lengths, we've been given the volumes now. Okay, so I'm going to find out my volume scale factor by dividing my two volumes. 540 divided by 20 gives me 27. If I want to find out my normal scale factor, I've got to cube root my volume scale factor. So cube root 27, 3 times 3 times 3 is 27, so my normal scale factor is 3. If I want to find out what x is on the bottom, okay, I've got to take that 4, and I've got to times it by my scale factor of 3. So the x on the right hand side is just 12 meters. Okay guys, pause the video now, get those down for me please. Right then, so what you'll find is here, I'd like you to have a go at some questions please. If you get this and you think, you know what, I got this in my head now, this is nailed. Okay, that's brilliant, you really understand this, and this is a difficult AA star topic. Okay, if you haven't quite got it yet, don't worry, just give yourself a little bit of practice and have a go. It doesn't matter if you get it wrong, no one cares, no one can see your work. Right, so mark what have you done so far. Okay, if you've got any wrong and you're really stuck, ask your teacher or ask me. And then the very last thing we're going to do, right, this is an actual GCSE question. Okay, have a look at it. Okay, pause the video, have a go yourself. This will come up towards the end of paper 2. Okay, so have a go and let me know how you get on. Right then, so hopefully you finished that now. Two similar periods of volumes, 3970 and 3100. If I've got to find my volume scale factor, because I've given the votes for volumes, I know that in my head already. The height of the larger pyramid is 25 centimeters. Calculate the height of the smaller pyramid. So we're going to be dividing. Okay, we're going to be making our larger height smaller. Okay, so I'm going to work on my volume scale factor first. Volume scale factor is 3970 divided by 3100. Not very nice numbers, but I don't think it's going to matter. 3970 divided by 3100 gives me 1.2806. We're going on for a while. Okay, I'm going to write 1.28 recurring. Okay, if I want to find out my scale factor, I'm going to keep that on my calculator because I want to be as accurate as possible. I've got to cube root that number. Cube root, and for my scale factor I get 1.086. That's my scale factor. Okay, now the height of the larger pyramid is 25. If you want to find the smaller pyramid, smaller height is the larger one divided by the scale factor 1.086. Gives me 23.02 centimeters for the smaller height. Okay guys, hopefully you got that somewhere close to being right. Okay, if you didn't, don't worry. Remember, this is all about learning, it's all about getting better. Hopefully you got some of the session correct and this is a topic you can go away and work on. Well done.